Alright, so in this problem, I have 2 to the power of 3 to the power of 4 to the power of x is equal to 512. So to solve this, I'm going to first start by rewriting 512. So 512, this is the same thing as 16 times 32. And now I can write this as 2 to the power of 3 to the power of 4 to the power of x is equal to 16 times 32. Now 16 is equal to 2 to the power of 4, and 32 is equal to 2 to the power of 5. So this is why we wrote 512 as 16 times 32, because now I have 2 to the power of 4 times 2 to the power of 5, and notice how we have another base of 2 over here, 2 to the power of 3 to the power of 4 to the power of x. So now I can rewrite this as 2 to the power of 3 to the power of 4 to the power of x is equal to 2 to the power of 4 times 2 to the power of 5. Now all my terms are bases of 2. Now, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So right here we have 2 to the power of 3 to the power of 4 to the power of x is equal to 2 to the power of 4 times 2 to the power of 5, which is the same thing as 2 to the power of 4 plus 5. And 4 plus 5, that's equal to 9. So 2 to the power of 3 to the power of 4 to the power of x is equal to 2 to the power of 9. And also, instead of doing all that, remember over here how we had at the start 2 to the power of 3 to the power of 4 to the power of x equals 512. 512 is equal to, well, we know that 2 to the power of 5 is 32, so 512 is 2 to the power of 5 times 2 to the power of 4, which is 2 to the power of 9. So we could have just said at the start that 512 is equal to 2 to the power of 9, but some people don't know that 2 to the power of 9 is equal to 512, so that's why we had to do all of that. So now going back here, we have 2 to the power of 3 to the power of 4 to the power of x is equal to 2 to the power of 9. And now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, we can say that m is equal to 3 to the power of 4 to the power of x, and n is equal to 9. So because these two bases are the same, this means that 3 to the power of 4 to the power of x is equal to 9. Now, 9 is the same thing as 3 squared. So now I have 3 to the power of 4 to the power of x is equal to 3 squared. And now again, I can use this property because both my bases are the same. So this means that 4 to the power of x is equal to 2. And now 4 is the same thing as 2 squared. So I get 2 squared to the power of x is equal to 2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x is going to equal 2 to the power of 2 times x, which is 2 to the power of 2x. This is equal to 2. Now, I'm going to use this property again. 2 is the same thing as 2 to the power of 1, so then because these two bases are the same, I get 2x is equal to 1. And now, if I divide both sides by 2, these two cancel out, and I get x is equal to 1/2. So now, to check, my original equation was 2 to the power of 3 to the power of 4 to the power of x is equal to 512. So I have 2 to the power of 3 to the power of 4 to the power of x is equal to 512. and we said that x is equal to 1/2. So I have 2 to the power of 3 to the power of 4 to the power of 1/2 is equal to 512. Now I'm going to work my way down from the top. So I first start with 4 to the power of 1/2. Now 4 to the power of 1/2 is the same thing as the square root of 4. And the square root of 4 is equal to 2. Meaning I have 2 to the power of 3 to the power of 2 is equal to 512. Now from here, 3 to the power of 2 is equal to 9. So I have 2 to the power of 9 is equal to 512. And finally, 2 to the power of 9, that's equal to 512, as we already said at the start. So we get 512 is equal to 512. Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 1. So, to first start, I'm going to rewrite 2 to the power of 25 as 2 to the power of 24 plus 1. And then we have our minus 1 at the end. And the reason I'm doing this, and rewriting 25 as 24 plus 1, is so now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So 2 to the power of 24 plus 1 is going to equal 2 to the power of 24 times 2 to the power of 1 minus 1. Now basically our goal throughout this video is to change our values to be as small as possible, so then at the end we can do whatever we need to do with them to get our final result. So 2 to the power of 24, how do we simplify this and make it even smaller? I can rewrite this as 2 to the power of 12 times 2. And another property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is going to equal 2 to the power of 12 to the power of 2, and I have this times 2 minus 1. So now I'm actually going to plug in the actual value of 2 to the power of 12, because 2 to the power of 12 is small enough where we know the exact value of it. So if you guys don't know what 2 to the power of 12 is, well, 2 to the power of 10, you should always remember this as 1024. So 2 to the power of 11 is going to be double of 1024, which is 2048. And 2 to the power of 12, which is the value we're looking for, is going to be double of 2048, which is 4096. So now I get 4096 squared times 2 minus 1. And now this is equal to, I'm going to simplify this, 4000 plus 96 squared times 2 minus 1. And the reason I'm doing this is because 4096 squared is really hard to calculate by itself. So if we change it to 4000 plus 96 squared, I can use the property a plus b squared is equal to a squared plus 2ab plus b squared. So in this case, a is 4000 and b is 96. So this turns into 4000 squared plus 2 times 4000 times 96 plus 96 squared. And I have all of this minus 1. Oh, sorry, all of this times 2 minus 1. Now, 4000 squared is equal to 16 million. 2 times 4000 is 8000, and 8000 times 96 is equal to 768,000. And now I have this plus 96 squared, which is equal to 9,216. And all of this I have times 2 minus 1. So now I'm going to add all these up. So if I add all of these up in the parentheses, I get 16,777,216. So now I have this times 2 minus 1. So if I multiply this by 2, I get 33,554,432. And I have this minus 1, which is equal to 33,554,431. So this is my answer to this problem.